Welcome to my channel. So in this we're going to learn about polynomials. The polynomial is built from variable and coefficient using only the operation of addition, subtraction, multiplication and the non-negative integer exponent. So let's see some examples of polynomials. X squared plus 10. So x is a variable, 2 is the exponent, operation is addition and 10 is the constant. Now 10x to the power 0. Such polynomials are called constant polynomial. Whenever the degree exponent of the variable is 0, the such polynomials are called constant polynomial, and we know x to the power 0 is always equals to 1. So this polynomial will give a constant value, that is 10. Now let's understand some keywords. Terms are the elements of the polynomial. Here we have two terms, x squared plus 10. Here we have one term. Here we have three terms. Here 3, here 2. Now let's see degree. So degree is the highest exponent of a variable in a polynomial. It's called degree. So in this the degree is 2, in this the degree is 0, in this polynomial the degree is 3, in this we have degree 3, in this we have degree 1. Now standard form. Standard form is the representation of the polynomial according to the descending order of the exponent. So here we see in the first term the exponent is 3, in the second term is exponent of 1. So it's already represented in the standard form. Now see the types of polynomial based on the terms. The monomials. Monomials are the polynomial with a single terms. For example, 10x to the power 0. So this is an example of monomials. The binomials are the polynomial with two terms. For example, x squared plus 10. So here are two terms. So therefore, it is a binomial. Trinomials. Trinomials means the polynomial having three terms. 1, 2, 3. Such polynomials are called trinomials. Now let's differentiate polynomials based on the degree. A linear polynomial. The polynomial with the degree 1, x minus 6 are called linear polynomial. Quadratic. The polynomial with degree 2, x squared plus 10 are called quadratic polynomial. And the polynomial with degree 3 are called cubic polynomial. X cubed plus 2x plus 6. So this is an example of cubic polynomial. So let's understand what are zeros of the polynomial. For example, we have px equals to x plus 5. On equating x plus 5 to 0, we get x equals to minus 5. So x equals to minus 5 is the zeros of the px. How? So for that, if we put x equals to minus 5 in px, we'll get the 0. So I think it's clear now that zeros are such the value of the variables. When you put in the equation px, the value of the equation px will become 0. So such numbers are called the zeros of the polynomial. Now see, number of the zeros. In linear equation, we know the linear equation, the degree is 1, therefore the number of zeros is at most 1. In quadratic, the degree is 2, so number of zeros is at most 2. And in cubic, the degree is 3, so number of zeros is at most 3. So now let's understand the number of zeros with the help of graph. So in the first graph, we see that the number of zeros is 1. Why it's 1? Because the graph of the equation is cutting the x-axis at one point, therefore its number of 0 is 1. In the second graph, we see the graph of the equation is cutting the x-axis at 2 points, therefore its number of 0 is 2. And in the graph 3, we have the equation of the graph is cutting the x-axis at 3 points, therefore its number of 0 is 3. Now, relationship between the zeros and the coefficient of the polynomial. In the case of linear equation px ax plus b, we have x equals to minus b by a. Now, in case of quadratic equation, let alpha and beta are the zeros of the equation px ax square plus bx plus c. Then x minus alpha, x minus beta are the factor of px. Therefore, ax square plus bx plus c equals to k x minus alpha, x minus beta. K is the constant. On simplifying, we get kx square minus k alpha plus beta x plus k alpha beta. Now we are equating the coefficient of x square, x and the constant. We get a equals to k, b equals to minus k alpha plus beta, c equals to k alpha beta. So by this we are getting the relation alpha plus beta, sum of root is given by minus b by a, and the product of root alpha into beta equals to c by a. In case of the cubic equation px, we have alpha plus beta plus gamma equals to minus b by a, alpha beta beta gamma gamma alpha equals to c by a, alpha beta gamma equals to minus d by a. So now let's understand the relations with the help of some example. Suppose we have a zeros alpha and beta of the equation py 3y square 5y plus 2. Now we need to find the value of alpha plus alpha beta plus beta. So for that we are going to use the relation we know, alpha plus beta minus b by a, alpha into beta equals to c by a. So now by this equation we have a equals to 3, b equals to 5 and c equals to 2. Now using the relation alpha beta minus b by a, so alpha plus beta equals to minus 5 by 3, alpha into beta c by a 2 by 3. Now adding the above two equation we get alpha plus alpha beta equals to minus 5 by 3 plus 2 by 3. So 5 minus 2, that is 3 by 3, we get minus 1. That means alpha plus beta equals to minus 1.